But today, more of the pieces for our projects come to us from a factory. Today, we're going to show you where those elements come from. We start where every project starts, at the foundation. The foundation always starts with digging a hole.
Heads up.
On some projects, that means blasting. Usually, a foundation starts with forms that are built on site and assembled. Rebar is inserted for reinforcement, and concrete fills the void. But there's a new way to make a foundation, and believe it or not, it's done indoors. Our journey to see how factories are so important to home building begins in Pennsylvania, where they're making precast concrete walls.
Doug, good to see you.
Good to meet you.
So you are Director of Operations, correct?
Correct, yes.
So when someone asks you why use a precast concrete wall, what are you telling them?
I tell them we have the ability to take your blueprints and do a custom design exactly as you like. We have the ability to pour it inside a quality controlled environment where we control the weather.
All right, well, how about giving us a tour?
Let's go. Here in our production facility, we're going to build about 5 or 6 foundations a day. We have 60 total employees. Each foundation takes about 3 hours to build. One of the insulation parts that we use is EPS. It's an expanded polystyrene. It comes in these large billets.
This is the kind of styrofoam cup material, right?
Exactly, same thing. What we're doing here is cutting stud insulation. The entire profile is programmed on the CNC machine, and we apply an electric charge to the wires, and it goes through and melts everything and cuts it to the exact specification.
Like a hot knife through butter, right?
That's exactly right. Here's a piece of stud insulation that was just cut on the CNC.
So the concrete goes into the cavity here, and then you've got the insulation here on the outbound side?
That's correct. Ryan's gonna take a piece of galvanized lath, and he's gonna bend tabs up so that the insulation can sit down on top of that.
Yep.
Holds it in place, and it also carries the rebar that's gonna go in the stud. Right here is where we're gonna start with your foundation.
This is our form?
This is your form. Right now we're spraying the form down with a lightweight form oil. This will keep the concrete from sticking when we're ready to strip the walls. So we're bringing a window frame in here. This is treated 2x8 framing. We're gonna set it on the deck, square it up, and we'll nail it down in place so it doesn't move during the process. Right now they're dropping in the studs that we saw produced earlier. They're gonna be spaced 2 foot on center. We're gonna put header and footer insulation at the top and bottom, which will provide the 2 foot spacing. We're putting number 3 rebar in the header and the footer. There will be 2 pieces in each, and then number 4 bar will be vertical in each stud. So now that the studs are in, the rebar's in, what we're gonna start doing is putting down the insulation.
Yeah.
Everything that we've done so far is kind of an opposite of what you're used to seeing from the inside of the foundation. So we're gonna put this piece of insulation in first. It's polyiso. It's gonna give us R6.5 per inch.
And it's foil faced?
Foil faced
For
for
what
fire
reason?
and smoke
Yeah.
prevention. Next, we'll have 4.5 inches of EPS. This gives it a combined R value of 21.3.
Wow, that is a nicely insulated wall.
So this is where we're gonna mix our concrete. We're gonna mix a 5,000 PSI concrete. We have 100% control over the mix because we're in a climate-controlled environment.
So if you guys are 5,000 PSI, what is it typically on a job site poured on site?
Sure, typically on a job site, you're gonna see anywhere from 25 to 3,500 PSI. And the reason for that is they can't control the conditions. You may have 5 or 6 trucks out there, you're sitting, you're waiting to pour, you're adding water and things like that. It just doesn't have the control.
What does the 5,000 get us?
5,000 allows us to guarantee these walls to be watertight.
Nice.
So we're pouring the concrete right now. What we have is we have a 1 3/4 inch face shell, and then we have a full depth stud cavity. So we actually have 9.5 inches of solid concrete at each stud.
But that skin is just going to be your 1 3/4, so that's not a lot of concrete. I mean, how much does that compare to a traditional pour?
We're gonna use about 1/3 of the concrete as a traditional poured wall.
Wow, that is remarkable. And so you can see the depth of the stud there. So that whole thing gets filled up with concrete. And then this right here is just your 1 3/4.
That's exactly right. And of course, the header and the footer is full depth concrete, and the load will transfer through the stud into the soil.
All right.
So this wall has been poured, it's sat overnight. We've stripped it, and it is ready to be hooked up and loaded onto a trailer.
Well, your oil work, that thing just slipped right out of there, no problem at all.
It's coming out the way it's supposed to.
The precast walls are trucked to the job site where crushed stone is leveled and ready to accept the panels. The pieces are then bolted together. After the foundation, framing is the next big job at our project. That means a load of dimensional lumber arrives at the job from a sawmill. But now, not all lumber is the same. As demands for taller, straighter wall units grow, builders are turning to new lumber products that promise more consistency and overall strength. I went to Canada, where there's a special mill that makes such a product.
So Kevin, this is the start of our process here. So these are the 8-foot poplar logs that are being loaded into the process. We call those magazines. So we've got this high lift loader that takes the logs either from a logging truck or actually from our yard. So this is the conditioning ponds and jack ladders. So the logs spend about 8 hours in the conditioning ponds. The ponds are heated up very hot, like 130 degrees during the winter, and it's really critical to thaw out the wood. So Kevin, we need to remove the bark from the logs. So we have each of the logs go through the debarker singularly. And we've got 5 knives that rotate around the log and cut the bark off. So we've created a pocket of wood here, and that's going to get pushed forward into the strander ring. The strander ring is about 8 feet in diameter or so. It's got 48 knives around the interior of the ring, and it'll travel through the wood and cut the strand.
So that big ring there, that's the actual strander, and it's going sideways across the wood?
That's correct. It's driven by 1,100 horsepower motor. And then it'll get indexed ahead for another cut. We're producing strands that drop off the bottom of that strander and go up the incline conveyor to some storage bins. This is one of 4 dryers that we have. The strands travel through here. They're being tumbled around like in a clothes dryer. And so they travel through to the end of the dryer. It takes about 15 minutes or so at about 1,000 degrees Fahrenheit to get down to the 2 to 3% moisture content that we need. And this is the control room. Over here we operate our blending, where we're blending strands with resin and wax. We're forming a mat through orienters to line up the strands in the machine direction, and that's outside here. And then we have a mat. Today we're pressing 1.5-inch wall framing products.
So essentially 2x4s that we use.
That's correct, yeah. The mat of strands is about a foot thick coming down the line. The forming process is a continuous one, so we have to cut that mat at some point. And we have a flying cutoff saw that starts to travel with the mat and cuts across. Then we accelerate the mat into the single opening steam injection press, which is very unique.
And how long is the mat, the one that you cut?
The mat's about 64 feet long,
Wow.
8 feet wide, and again about 12 inches thick for this product. Mm-hmm. It goes through the pressing process and a very unique steam injection press, which softens the mat with steam and helps cure the resin. After the mat then becomes, we call it a billet, and it'll actually go through a splitter saw that'll split the billet in half, 4 foot, 4 foot, for example, and goes down a roll case into a billet cooler. We need to cool it off for a couple hours so that it stops off-gassing.
Can you cut them once they're cooled?
That's correct. Then we'll go to our products area, which is really just a sawmill that cuts the billet down to size. We make something like 500 different products out of timber strand, out of LSL. This represents the kind of range from a 2x4 wall framing material, all the way to this 3.5-inch by 11/7/8-inch header that's used above garage doors and above walls and windows.
And everything in between.
And everything in between, yes.
Bill, I really appreciate the tour, and I know we've got more of this coming to our house, so I'm thanking you in advance for that delivery as well.
Thanks very much.
Appreciate it.
We've used concrete and lumber for building materials for thousands of years. But plumbing has only been a regular feature of the building process for a little over 100 years. Richard went to Wisconsin to see how tubs are made.
For a plumber like me, a foundry is like the chocolate factory for Willy Wonka. Steve Bruce is our tour guide today. Steve,
Hi.
what are you building today?
What are we doing? We're going to make some cast iron lavatory.
All right, so how does the process start?
First, we start with raw material.
Great. Look at this place.
Here's our scrap piles. We got a lot of scrap here, as you can tell.
I see old bathtubs and stuff like that.
Those are pieces that didn't quite make it out as A1, so we bust them up, we recycle them, we melt them all over again.
All right, so what's going on here?
We're making molds of cast iron lavatory.
Okay.
You take a sand mold at the top side and the bottom side of the mold, put the two together. In between the two now there's a space when you put them together.
A little gap in there.
A little gap in there, and that's what we're going to pour the iron into.
Okay. Look at that.
And here's what we got.
Okay. So they pour the molten cast iron in there, and then it cools, and then what happens?
It cools off downstairs, we break it open, and then we process it, clean it up, so it's ready to enamel.
Okay.
So why don't we go see them enamel them?
All right, great. So we've got our cast iron tub, and that's big, good, and strong, but we need to cover it somehow, right? Otherwise it'll rust, it's not hygienic.
If we don't coat it with enamel, it's going to rust.
Okay.
So we put on powdered glass, which is the enamel.
Okay, is that it here?
And the process, it's nothing more than powdered glass. It feels like
Sort of gritty, more than talcum
talcum powder almost.
Great. Okay, so how do you get that? Take us through the steps of the
We
process.
preheat the bathtub to about 1700 degrees. Then we put it in the melt furnace, bring it up to 1800 degrees, and apply a layer of powder to it.
Oh, so it's sort of like sifting the
We
glass
sift it
onto
on top with a vibrator, and it goes on top. We put it in the oven and it melts. 2 minutes later, we put another coating on. And that one melts for 2 minutes, and then we bring it out. At that point, all we do is cool it off, and you've got a finished bathtub.
That cake is done.
That's it.
Doors are a key element of any house. They can be made of fiberglass, steel, screen mesh, even glass. But it's hard to beat the craftsmanship of a solid wooden door. There's a family-run factory in Ohio that still makes them the old-fashioned way.
And so we find ourselves in our grading shed. And what's going on here, as you can see behind us, Gary is grading the lumber. In grading the lumber, that involves checking for the quality of the grade, this being an FAS material, first and second 5/4 white oak, and also for the volume. You know, we receive this lumber, it's 60–80% moisture content off the green sawn logs, and we have to take it down to a 6 to 8% moisture content.
So this is from the kiln?
This is from the dry kiln, so this is dried poplar, ready for manufacturing, and this is the first step of our manufacturing process here. It'll traverse through a planer. That planer is addressing both faces equally, so when it comes out, we have a nice flat surface on both faces of the lumber.
Heads over to a saw.
Heads over to an automatic gang rip saw that when that board and its index number gets to that saw, the saw automatically adjusts on air collars and resets itself for that board. Now that we've cleaned up the edges of the board, we gotta take care of little knot issues like this along the body of the board. This machine does that. It's an MRI for wood.
It's taking a picture of the board going through that quickly?
Takes a picture of the board, identifies the defect,
Right there.
ear tags it, sends it down the line to another saw that'll identify it to have it be cut out. That's optimizing our natural resources. Here's where we make our face veneers for our door styles. Put 5 pieces in, enters a saw, goes into 15 bandsaw blades, move up and down.
Blades being right there.
Yeah, those are the blades. They move up and down, and coming out we'll have 20 face veneers when it's all done. Okay, Kev, as you can see, our face veneers have been applied to the core for our door styles,
Yep.
and we're sending them through the motor. As you can see, with one pass through the motor, both edges and both faces have been addressed. Profiled edges, profiled faces, and then a groove cut in ready to receive that flat panel for our Craftsman style door. Okay, so now that we have all the parts and pieces and all the boring done, we're getting ready for assembly on this 4-panel door.
Got some really good looking doors. It's no surprise you've been in business for over 3 generations, so thank you.
We've framed the house, we have plumbing and doors. Now it's time for windows.
A wood window with an aluminum clad, so no maintenance to the outside at all.
As usual, the process starts in a factory that makes something called float glass, a molten mixture of ingredients that float in a bath of hot tin. As Richard found out, that mixture comes together in a giant silo.
You can see the silo is split into 12 different pie-shaped compartments.
Oh yeah, sand, limestone, all the ingredients.
Right, and then
They're
we
all
weigh
up
up,
there.
and then we weigh up each of those materials individually on the scales. Once everything's weighed up, it dumps into the mixer. Once everything is thoroughly mixed, we dump everything onto a conveyor and then transport that material across to a bin behind the furnace so we can melt everything.
Heat it up.
Right. So our batch feeds in from the batch house into the furnace here.
Right here?
Our furnace runs about 3,000 degrees. We use about $500,000 of natural gas a month to
Every
heat that
month.
furnace.
Wow.
The furnace itself holds about 2,000 gallons of melted glass.
Okay.
And what we're feeding in right now, we'll see as glass in about 6 hours.
Okay.
So show us what it looks like melted.
Oh, look at that. So it's already turned to goo. It's already turned molten. So this is all filled with molten glass?
Yes. And when the glass comes to the canal, at this point it flows into the tin bath. In the tin bath, we melt tin, varies between 2 and 4 inches in depth.
Yeah.
As the glass pours in, it's about 1/4 of an inch thick. It spreads out over that molten tin, and then we're able to start putting those top roll machines out on the very edges and stretch that to the width and thickness
So you
that
can
we
stretch
need.
it like a taffy, pulling it to a sheet.
Right.
Each one of them pulls it a little bit more, pulls it a
Right.
little more, so
Right.
it becomes a narrow sheet. Does this leave a mark in the glass?
Yes, it does. And then we cut that off and recycle it.
Good.
Here we come to the end of our tin bath, where you can actually see the glass being pulled right off of the tin.
Oh yeah, I can see it moving along there. The tin end's right there, and then it continues. Wow, it's moving right along too, isn't it?
Right. And then we look at the exit here, and we can see the whole ribbon of glass.
Oh, look at that. And it really is formed beautiful. Look how clear and clean it is. All right, how hot is the glass at this point?
About 625 degrees Celsius.
So still plenty hot.
Right. From here, clear down to that overhead door, we're going to cool that glass down.
This
so we
whole
can
thing is
cut
to
it.
cool the glass.
Right. The glass is now cooled. We're ready to start inspecting it, cutting it. We start by looking at the thickness, and then we'll inspect the glass itself for any defects.
Okay.
Here we have cameras that are looking for any of those defects. You can see the defects
You can
on the
see it'll make an
monitor.
impression right here, and it follows it all the way through.
Right.
So this is our glass. Can I touch it?
Yes.
Okay.
So you can see the
So it's
ripple
glass. You
pattern.
can feel it's glass. It's still got a little bit of temperature, and you can see those ridges in there from the top roll.
Right, we'll cut those off and recycle all of that.
It's just so beautiful. My goodness.
The defect system sees the defects within the glass. Once the glass passes through here, we're able to spray paint any pieces of glass with the defects.
Oh, it's a little spray gun. Oh, look at that. It just put a little pink dot on it, so that must have been a bad piece.
Right. The glass has now traveled 450 feet since it came off the tin. It's time to start scoring it.
Okay.
Making the cuts the long direction of that ribbon is fairly simple. Here we're making all the cuts going across the glass. You can see it's at an angle.
So that's not as easy, is it? Because this is moving. You put this thing at an angle, and it has to come back at the exact same speed as it's moving this way to make a perpendicular cut.
Absolutely.
That is so smart. All right, so here's those marks from the top roller. And just like that, it's gone.
Right, we recycle that as cullet, one of the ingredients we saw when we started.
Nothing gets wasted.
Right. We take the glass off the line both manually and robotically. This is one of our manual packing lines.
Look at this. There's one of our pink dots here.
When that gets to the packers, they'll break off that edge and throw it down the chute so we're able to recycle it.
Oh, look at that.
The raw glass gets treated and then delivered to a window factory. This one's in Minnesota on the Canadian border.
This is our casement sash line. Now we've got a frame that's been glazed.
Nice.
Now he's going to space it. Keep
Even
everything
on all sides.
That's right. You got to keep it even.
So this is where it's starting to look like a window.
That's right. And drops completely in, and down the line it goes. Now we're ready to apply the aluminum cladding.
Yep. Oh, wow, that's aluminum, huh?
That's right. As Mung taps this in, take a look at that. That exterior finish is the best in class.
It's a lot like wood.
Yeah, beautiful. Now it's going to go into a press. We're going to apply uniform pressure all around it, and we're good to go. Okay, well, we're almost at the end of the journey. We've got the frame here. Now we're going to install the sash.
The two of them coming together. That's nice.
That's right.
So even though these guys are doing an installation, they're also inspecting